In this lecture, we're going to start our discussion of methods for decomposing rational expressions using what's called the method of partial fraction decomposition. And the two cases that we're going to look at in this lecture are ones where the denominator can be factored into linear factors, where some of the linear factors may be repeated. In other words, we might have an x plus 2 squared instead of just an x plus 2 like we have here. You remember what the goal is. The goal is to take this rational expression and rewrite it as the sum of two or more rational expressions, where the denominators are smaller, in the sense that they have the degree of the denominators is smaller, or the denominators have fewer factors. Okay, so here's how we do this in the case where we have non-repeated linear factors like we do here. So what I'm going to do is I'm going to say, look, I'm going to start with the original expression. Right, it's this thing. And I want to rewrite it as this. I want to rewrite it as a over x plus 2 plus b over x minus 4, where a and b are going to be constants. Those are going to be numbers that I have to solve for here. And hopefully, again, remember that fundamentally this is a calculus class. Our goal here is to be able to integrate these rational expressions. And hopefully you can see pretty quickly that that right side is going to be a whole lot easier to integrate than the left-hand side is. Okay, so now what I need to do, I need to solve this for a and b. All right, so what I'm going to do is I'm going to do just what you did back in your algebra classes when you were dealing with rational equations. I'm going to eliminate the denominators. All right, so I am going to multiply this whole thing by x plus 2 times x minus 4. Right, because when I distribute this here, right, you know how we do this, we distribute this to every term inside here. The left-hand side becomes just 2x minus 1. And the right-hand side is a times x minus 4 plus b times x plus 2. Okay, now I'm going to rewrite that right-hand side. And what I'm going to do is I want to group it so that it kind of looks like a polynomial. I want to have something x plus a constant. Right? So to do that, I'm going to start by distributing. This is ax minus 4a plus bx plus 2b. Then I'm going to group the x's. This is a plus b x minus 4a plus 2b. And remember, this equals, I'm going to write it out, 2x minus 1. Now, for two polynomials to be equal, right, and that's what I've got here. I've got a polynomial on each side of this equation. For two polynomials to be equal, their coefficients have to be equal. Right? Specifically, the coefficients of their individual terms. So the coefficients of the x terms have to be equal, and the constant terms have to be equal. So let's write that. Setting the x term coefficients equal, I get a plus b equals 2. And doing it with the constant terms, I get negative 4a plus 2b equals negative 1. Excellent. Now look at where I am. I have a system of two equations in two variables, and we know how to solve those. Right? We know how to solve these. So what I'm going to do is I'm going to take this first equation, I'm going to multiply it by 4. Right? If I do that, this becomes 4a plus 4b equals 8. I'll add these together. This is 6b equals 7. B is equal to 7, 6. Yeah, kind of a weird fraction, but that happens with these things. So you got to kind of be prepared for it. All right, now I'm going to substitute into the other equation, back into the other equation, and I'll get a value for a. So this is a plus 7, 6 equals 2. If I subtract 7, 6 from both sides, a is 2 minus 7, 6. 2 is what? 12, 6. So this is 5, 6. And there are my values for a and b. Right, now remember, to get the final answer, okay, I'm going to take those two numbers and I'm going to substitute them back into here and here. And if I do that, I get 2x minus 1. This is the original polynomial over original rational function. X plus 2, x minus 4 equals. Now, how do we write this? Well, here's how I'm going to write this. I'm going to write it 5, 6 times 1 over x plus 2 plus 7, 6 times 1 over x minus 4. Now that's one way to write it. Another way to write it, I could have just put the fraction in the numerators, 5, 6 over x plus 2 plus 7, 6 over x minus 4, or I could multiply these things out. Right? I could say this is 5 over 6x plus 12 plus 7 over 6x minus 24. Which one is right? Well, they're all valid answers. They're all equal to each other. And my advice to you as a student is to watch what your professor does, right? And look at how your professor formats the final answer and stick with that one. Okay, now the reason that I choose to write it this way, leaving that fraction just floating out in front, is because I'm looking ahead and I'm saying, look, remember, it's calculus class. At the end of the day, we want to integrate this thing, right? And if I can pull that constant out in front, that makes my life that much easier because now I don't have to worry about it. Now I can just integrate these things, which you can do pretty easily, right? It's 2 logarithms. And I don't have to worry about that constant. If I had the constant in the bottom here, I'd be doing some kind of U substitution, and it just gets messier than it needs to be. And that's why when I do these, I'm going to leave that constant out in front because I'm looking ahead, and I know that's going to make my life easier. Okay, so how about this one? It's almost identical to the last one, right? Almost identical. The only thing different is I threw an extra exponent in here. Right now, that x plus 2 factor, it repeats, right? Technically, it occurs twice. It's got multiplicity 2 if you want to use the fancy language. Okay, so how am I going to decompose this? Well, I am going to do practically the same thing, right? Practically the same thing. I'm going to start off with the original polynomial. I keep saying polynomial. With the original rational expression. Over x plus 2 squared times x minus 4. And here's what I'm going to do. Here's the only twist, right? I'm going to have the a over x minus 4. That stays the same. Plus, now here's where it gets a little different. B over x plus 2 plus c over x plus 2 squared. So every time you have a factor that repeats, it gets an extra term for each degree, if you will, of the exponent. Now, this is as high as we're going to go. As I've said before, my goal here is not to set really nasty algebra problems because it's a calculus class. I want to see if you can do calculus, not if you can do really messy algebra. So I'm going to stop at exponents of 2. However, if you go higher, if you see something with an x plus 2 to the 4th, for example, you extend this in the obvious way. I would have dx over x plus 2 to the 3rd plus e over x plus 2 to the 4th. You kind of, like I said, extend it in a very natural way. Okay, but now I want to solve this. So I'm going to do what I did before. I'm going to get rid of that denominator. I'm going to multiply through by x plus 2 squared times x minus 4. Right, if I do that, right, distributing this thing in here, we get 2x minus 1 equals a times x plus 2 squared plus b times x plus 2 times x minus 4 plus c times x minus 4. And yes, even with just a second degree one, right, it's still going to get a little messy. Because now I got to multiply these things out. This is a times x squared plus 4x plus 4 plus b times x squared minus 2x minus 8 plus cx minus 4c. Now I'm going to distribute. This is ax squared plus 4ax plus 4a plus bx squared minus 2bx minus 8b still plus cx minus 4c. Now, just like we did before, I'm going to group the terms together. Right, so I have these 2x squares here. I like to mark these somehow, just so I know which terms I've used. It helps me make sure I don't accidentally forget one. So this will be a plus b x squared plus, now I have to do the x's. It's going to be this one, so it's plus 4a minus 2b, whoops, I didn't change the color back, minus 2b, and this one here, plus c, and then all I have left are constant terms. So this is plus 4a minus 8b minus 4c. And now we do what I did before, right? Let me write this. So this is 2x minus 1 down here again. I'm going to match up the coefficients. So I'm going to get 4a minus 8b minus 4c equals negative 1. And I'm going to get, well, I left out the x. Put an x in there. I'm going to get 4a minus 2b plus c equals 2. And finally, a plus b equals 0. Because that would be the, there is no x squared term. Unless you can think of its coefficient as being 0. Okay, now what am I going to do? We have three equations and we have three variables. Now that third equation doesn't have a c in it, and if that caused you a little concern, that's understandable, right? When you did these in your pre-calc class, sometimes you ended up in a situation where there wasn't a solution, especially when you ended up kind of missing a variable like we are here. It should always be able to do this, so we really shouldn't run into a problem solving these things. But here's what I'm going to do. I'm going to take this third equation. Say, look, this means a equals negative b. All right, then now I'm going to substitute negative b for a into the first two equations. So this becomes negative 4b minus 8b minus 4c equals negative 1. When I do it into the second one, we get minus 4b again, minus 2b plus c equals 2. All right, so let's keep going. Right then, this is minus 12b minus 4c equals negative 1. And over here, it's minus 6b plus c equals 2. Good. Now we're down to two equations in two variables. So let's multiply this one by 4. So it'll be minus 24b plus 4c equals 8. And if we add these together, this is minus 36b equals 7. So b is negative 736. Okay, not the prettiest number, but that's all right. So now let's substitute into this one, right? If I substitute into there, this becomes negative 6 times negative 736 plus c equals 2. So let's see, becomes just positive 76 if we simplify that fraction. Plus c equals 2. Subtract 76 from both sides, and we get c is equal to 56. All right, and finally, jump back up to here. A must be positive 736. And now we get our decomposition, right? It's going to be, make sure I get all my fractions right, 736 times 1 over x minus 4 minus 736 times 1 over x plus 2 plus 56 times 1 over x plus 2 squared. And there's my decomposition. Again, hopefully you can see the motivation behind this. Integrating this expression here, right, would not be particularly difficult, and that is ultimately our goal. Okay, so that's the situation where you have strictly linear factors. In the next lecture, we're going to kind of take it up a notch, right? And we're going to look at what you do when you're looking at a rational expression that has quadratic factors in the denominator.